Van Walt is a bespoke team of individuals in 5 offices across 3 continents who design, source, install, supply, rent and repair equipment for environmental research. For more than 40 years, we have developed our expertise and experience to bring you best-in-class equipment for soil water and groundwater monitoring and research. Listening to your needs, using our experience and expertise to offer solutions that help you meet your objectives each and every time. Developing the equipment you need to protect the world's resources for future generations. Van Walt, monitoring your needs. Greetings, welcome back to the Environment Monitors, Van Walt, the Environment Monitors. It's podcast number, what are we up to? 4. We're up to number 4 this time. And let me put the banner up because this time we're digging deeper, I know, into soil augers. And you'll be good to know, again, it's not me. I'm not the expert on this. We got the main man back again. It's Vincent Van Walt. Let's bring him in. Greetings, Vincent. How are you?
Good morning. Yeah, pretty well, thanks.
Good. We're going to dig into something today, Vincent, that actually sort of made me sit up and take notes. Something that I thought was very straightforward and have since found out it really isn't. There's a whole lot to this, and that is obviously soil augers. But before we delve deeper, in a snapshot, what is a soil auger?
Well, a soil auger is really a device mostly made of metal, which allows you to take a sample of sediment. So pretty straightforward, really.
Yeah, absolutely. And that's my point, is that it sounds like it's straightforward. I mean, why would we want to sample? First of all,
well, that's really the question. Assuming we don't take samples for fun, there will be a reason why we want to take a soil or sediment sample, and it's that reason which determines what tool you should be using. So a soil auger is more or less a generic term for any device that is able to take samples. The whole question it relates really back to, why do you want to do this? What is the purpose? Is it archaeological? Does it have to be? Can it be disturbed? Can it be semi-disturbed? Must it be undisturbed? Because in the first instance, if you just want to take a sample of your back garden, take a bucket and a spade, and essentially that becomes your soil auger. That is one way you can take samples, and there is nothing wrong with that. But in some cases, we have to be a little bit more scientific about how we do things.
And I'm assuming, therefore, the phrases you just used there of disturbed, semi-disturbed, and undisturbed, that is a self-explanatory, as in there are situations where we need to get a sample, but we can't mess up everything around it. Is it simple as that?
Yeah, it's simple, but not so simple.
Yeah.
It's the purpose, really, of the sample that you wish to take. Let's take an example. You want to test your soil for nutrients in the top layers, and in that case, you can take a little trowel and you can take some bits of soil, put them in a bucket, mix them up, send them to the laboratory, and you have, from that composite sample, you can then determine the status of the chemical status of your soil. When you're looking at undisturbed, and that means that the profile of the sample is maintained. By profile, I mean from top to bottom, it retains its integrity and it shows exactly which layer you're in. That becomes more complicated. And you have, therefore, to find a device that is able to do that. And I'll give an example. If you're measuring the transport of pesticides or herbicides into the structure of the soil, you will want to know at which horizon do you have a particular level of pesticide. Consequently, when you're taking that sample, you must absolutely make sure that you preserve the profile, because otherwise, if you mix it all up, you don't know whether that pesticide has penetrated the top 5 centimeters or has percolated down to 30 centimeters, for example. Another example might be when you're trying to determine residual nitrogen or nitrates. So the farmer might top dress his field with, let's say, ammonium nitrate, and he wants to see how is that transported, how is that leached. So when it rains, it dissolves and it moves down in the various profiles. And you want to know which depths has it actually reached. And therefore, an undisturbed sample of a particular horizon is really, really important, because you may have 0 nitrates, let's say, in the first 30 centimeters, but you might find that you have a substantial reservoir in the profile from 30 to 60 centimeters, or even from 60 to 90 centimeters. And therefore, you have that reserve and you know it's there, and you may therefore come to a situation where the farmer will say, well, I don't need to top dress anymore, because in fact, I have this reservoir I can tap from, or my plants can tap from.
And that makes sense now. I get it. So the undisturbed is actually the profile of what you're extracting with that auger, rather than around it.
I think another example might be where you're wanting to look at roots. Just imagine that roots grow in the top meter, but you want to see what is the health and the status and the quantity of roots. Now, if you take a bucket and spade and just dig a hole and mix it all up, you actually don't know where those roots are. And in those circumstances, you may say, well, I want to know exactly what is the status, what is the quality of my roots in the top 20 centimeters, and then the 20 to 40 centimeters and so forth. So you cannot disturb the samples, because by disturbing the samples, you're ending up with results which are nonsensical. Now, there is a problem with this, and the problem is that the devices which are used to take undisturbed samples are actually different and more complex if you want an undisturbed sample. So the least disturbed the sample you want, the more difficult it is to do that, which is actually why we have such a huge variety of different sampling solutions.
And this leads me on. Sorry, Vincent. This leads me on really to where I was trying to get to the bottom of the fact that while we've got pages and pages of augers available in a catalogue, is because you need to make a decision. So you don't just suddenly turn around and go, well, just in case we want it undisturbed, we'll go with that. It's like, no. If you don't need it, you've got an easier auger to probably use, because it's just hoik it out. Whereas if you know you need to understand a profile, then we need to look at the right tool for the job. And that leads to the question, does that mean there is a right tool for the job when it comes to augers?
Yes, I think the crucial factor comes back to, why do you need the sample? So you really need to determine that. Now, if it's for a research project, it'll be different than if it is to get a ballpark idea of what's happening. So if you're doing serious research, you will want probably to take undisturbed samples, but there is a cost implication. So taking a disturbed or semi-disturbed sample is relatively easy, and it's relatively cost effective. In fact, it's very cheap to do that. As I mentioned earlier, you could take a bucket and a spade, which is probably the cheapest route to that. But if you're doing deep research, you have to take the tool which is correct for that particular research. I just want to get one thing out of the way, because there is a lot of discussions about soil and sediment. A lot of people use the terms to describe the particular consistency of the material. To get this myth out of the way, soil is sediment, and therefore we tend to refer to the soil as sediment. In some cases, people assume that sediments are the weaker soils, the muds, the uncohesive, high organic matter material. Now, that is not the case, although we have to take account also of what the soil matrix consists of. Is it highly organic? Does it compact easily? Is it very flowable? That is, that you may not be able to retain the sample because it is very loose and very fluid. And that also is important when you're determining which tool do you use. Now, just imagine that you're taking a sample of very muddy material, to class it in an unscientific way. You do this with your spade. What's going to happen? You take a spadeful, it's all going to flow away from the spade, and you have no retention. And therefore, you have to make a choice of the correct tool in order to give you that undisturbed sample.
Yeah, because when I was looking at it, there's a mixture of based on what we're digging into, if you will, that can change the cut almost that we need to do. But there's then the retention. What do you need to retain? And that includes, I even saw a cylindrical one that said if you've got sort of quite claggy soil, it's just going to clog it up. It's just going to be stuck in there, and you're going to spend the rest of the day even trying to get it out of that unit. So there's an awful lot of thought that needs to go into this. And this is why, I mean, our queen of the augers is Icky, and she's involved in constant conversations with our customers and our partners. And it makes sense why that would happen, because it's okay, you know, what, where, what, why, and hence she's even sometimes involved in bespoke auger situations as well.
Yes, indeed, and I think the program that companies like ours have is incredibly wide, but constantly, and I would say on almost a weekly basis, somebody will say, "Well, I want to take a sample, an undisturbed sample of sediment in a particular horizon. How do I do it?" Even with our 300-page catalog, we may find that we do not have the correct tool, and then we work with our partners to produce something that will actually satisfy the requirements of the project. So let's take pesticides. Classically, it was the top 30 centimeters, but some people wanted the top 50 centimeters, or some want the top meter. So it varies depending on what the requirements are.
Yeah, and I mean, I was looking at some of the examples, soil type, and we'll come onto that in more detail in a minute, because that's a subsection in its own right, isn't it? Even a simple one, where the sample is located, because we can, as well as like work out, right, that's the auger you need. There are obviously sets that you can get with interchangeable heads and handles and all sorts of things. But if you're going up a blooming great big hill, you don't really want to be taking a whole set up there if we can actually go, well, this is the one you actually need, and you're only carrying the one up there.
Yeah, that's a question that arises all the time. Customers assume that a mechanized solution is actually the easiest solution to work with. And that is often not the case. In the example that you give, you've got to take the sample on top of the hill, or indeed in a cave, or in confined areas, and you might find that you cannot carry mechanized equipment. Also, mechanized equipment, they do have a place, but they are, by definition, they are heavier than a simple hand sampling device. I want to go back to really the scope of the research, and define a little bit the sectors which consider this undisturbed sampling, which I think we probably need to focus a little bit more on, because that is the more complex of the sampling. So you have agricultural soil science. Usually that will be chemical analyses, be it nutrients, be it pesticides, herbicides, treatments of soil, so additives that are put into the sediment. But we mustn't forget the archaeological sector, which has an enormous requirement for undisturbed sampling for obvious reasons. If you are taking the sample, you want to know where your archaeological artifacts are. It's important to know they are at 1.50 meters. The other side, which we've been involved in increasingly, in fact, is on climate change and dating of samples. You want to see where there is an accumulation of sediment. You want to know where does it come from. You want to know what age is it. How did it get there? And for that, you will absolutely need undisturbed samples, because if you mix it up, you might find that you will not be able to determine the age of the sediment.
For me, it'd be like ripping off the spine of a book, throwing the pages up in the air, and then trying to bring it together, and then reading it in whatever order you've got it. It's never going to make sense, is it?
No, that's correct.
No, I find that amazing. I mean, we're talking about a profile there, but we need to also be able to look at, okay, what depth or size does that sample need to be? You've touched on that. That is important as well. We need to get that right. And one of the other ones that I was seeing is whether it's, I mean, it all makes sense the way you're explaining about seeing this profile, for example, but it can vary between a visual on-site inspection, I guess is the right word, or whether it's taken away to a laboratory to analyze it in more detail, but maintaining that profile as well.
Yeah, most of the work that we're involved in, that absolutely, there is a dual aspect. Normally, one would take samples. You would, as you retrieve them from the ground, you would make a visual assessment. Usually that means a logging event. It'll mean photographing. And then it'll mean transporting that to a laboratory for dating, for chemical analysis, for whatever purpose you require afterwards. But that brings yet another aspect to what is your project, because if you have to transport the samples in an undisturbed way, you must therefore be able to use a tool which enables you to do that. So if you have a tool which gives you the profile, but you've got to take it out of the device in order to store it, by doing that, you're actually disturbing the sample, and therefore the chain breaks, because by the time the laboratory gets it, it's been mixed up, and therefore you don't have you don't know what you're looking at anymore.
It is this is everybody listening can now sort of get an idea probably of why I found this so intriguing once I started digging deeper. Apologies for the pun there, but it just, there's so much to it. Is it what's the difference between using an auger and window sampling then?
Okay, no, they're completely different. So an auger has a shape to it, and what you're doing, you're screwing that into the ground. So you're rotating the device in the ground, and by doing that, the blades of an auger will capture the sample within the blades, and you can retrieve that a little bit at a time. Usually 20 centimeters, 15, 20 centimeters at a time. Now you can build a beautiful profile like that. So you do not always need to use a device that gives you continual samples, because that is really the difference. Do you need a continual sample over a certain length? When you come to window sampling, that does use mechanized devices. So you will be inserting those through a mechanical a device like a breaker that you see on the roads, and you're driving steel, what actually are just steel rods, into the sediment, and capturing the sample within that tube. The window sample is nothing else but a steel tube with slots cut into it, and those are the windows. So there's nothing particularly sophisticated about the device. Now, at that stage, when you retrieve that window sampler, and usually they come in lengths of 1 meter, so you will get the whole profile over a meter. That gives you more or less, and if you're careful and if you've been trained correctly, and we spend a lot of time in training people how to do this, to avoid compaction, to get the maximum retrieval from that window sampler. You then come to stage 2, which you were mentioning earlier. Yeah, I want it back in the lab to carry out further analysis, and therefore you've got to get the sample out of the window sampler into something else that you can transport. And this is where the window sampling sets are normally expanded by using a windowless sampler, which is a steel tube but without the windows cut into it. And within that, we capture the sample within a liner, and the liner can be low density polyethylene, very thin plastic material, or it can be more rigid material. And those then are pulled out of the sampler as a whole meter profile, and they will then go to the laboratory where they'll be stored and then analyzed further. So the window sampling is actually an extension of hand augering, shall we say, where you are using a mechanized device, and usually, and a window sample is no good really for the top meter. You've got a lot of equipment there to go down 1 meter. It's usually to go down to greater depths, let's say typically 6 to 8 meters. You can go into heavier sediments as well, and using a standard hand auger would be pretty tiring to go down to depth, especially if you have to take a lot of samples. But this is an important point, is in this company, we always try and entice people to go for quality of sample rather than quantity. Over the 40 years, I get PhD students, and they explain to me what their research is going to be. And one of the questions I ask them, well, how many samples do you wish to take? And they come back with, I want to take 1,000, or I want to take 2,000. And my standard answers to them is, no, you don't take 1,000 meters, you take 10 meters, or you take 20 meters. And work on the quality. So it's not just the tool that you're using, it's the accuracy of using that tool to make sure that you get a representative sample of what it is that you want to do research on. So you need to spend time to get that accurate sample. And the more undisturbed you want it, the more difficult it's going to be, and actually the more expensive it's going to be.
Sure, absolutely. I mean, that was really a very personal question, the window sampling and augers. But if anything, the key thing that stands out to me is that what you always want to do is explain to us what it is you're trying to achieve. And we can help. You know, there's the catalogue there that you can just pick it if you know exactly, but let us assist you. We work with you. As I say, Iki gets involved in conversations with our customers, our partners, our suppliers, and it's about finding the right thing. I mean, even down to basics in the way that you put it in. I mean, I've seen the hand twisting version, we've got hammering it in, you know, there's a variety of ways to get it into the soil as well.
Yes, yeah, well, generally these are hand tools, so most of the devices for taking shallow samples will be tools which can be carried easily by one person, inserted easily by one person, and retrieved easily by one person. They're built like that. In fact, if you use two people to use a standard hand auger for a semi-disturbed sample, you're likely to break it. So these things are rated for the use of one person. With the exception of window sampling, which, as we discussed, it is a mechanized device which requires a minimum of two people. But where am I going with this? These are hand tools. These are tools that have to be used within the specifications, within the tolerances of that particular device, and therefore mostly they're addressed for one person usage. Where you talk about window sampling, absolutely on a health and safety, from the health and safety perspective, you really do need to have two people. I just want to introduce another set of tools, and whether they're augers, and I think augers is a little bit of a misnomer, because we're talking here of sediment sampling equipment, and yes, hand augers are part of it, but there are other devices. But one particular one that I just want to highlight is, let's say that you want to work on the soil moisture determination curve of a particular sediment structure. Now that requires extremely accurate samples, and we work with very precise rings on a precise volume, so we can determine the moisture content of soil ring sets. Now they're made to extremely tight tolerances, so you get exactly the 100 cc that you need for this particular experiment. So again, that is why the buffet of choices is so big, because you could not do a PF determination without the particular ring sets that we have for this specific purpose. You can try, but actually the results will not be very good because of the accuracy required to carry out this particular project.
Again, coming back to make sure speak to us, because there's a lot more in the kit bag than you might realize, which we find very often. One of the things as well, where you were talking about it's hand tools for one person, and I even happen to mention if you're suddenly disappearing all the way up a hill and you don't want to take a whole set just in case you need this or this. There's also, it's not suddenly an excessively long piece of kit, because you're able, I love the way that the extensions fit with the bolts and the jackets and putting it together. But how deep can you realistically go down with a hand auger, roughly speaking?
Well, let's drill down first into why we have so many hand augers. There is no such thing as a heterogeneous soil. They're all different. And you can imagine that clay is very stiff, can be very hard going. So the hand augers made for clay have thinner blades, so it is easier. It makes it easier for the operator to actually extract the sample. If you're in sand and you use one of these hand augers with very narrow blades, you're just going to lose a sample. And therefore, there will be an auger for sand and for coarse sand, very gritty sand, or indeed, if you want a flat surface, so hard, dry soils would be a type of riverside condition, you will have different augers. And let's bring health and safety into this. Potentially, you could take a sample of heavy clay soils with a standard, what we call a combination type auger. You will get it in the same way that you will get it if you use a spade and a bucket. However, it's the effort to get that sample. And at Van Walt, we look at the health and safety aspects of these things very, very carefully. You use the wrong tool, you're going to overexert your body. And it is the shoulders, it's the neck, it's the back, which takes the impact or takes the forces that you use. You use the wrong tool, you're potentially going to come into a situation where you are going to hurt yourself. And therefore, yes, there's a whole selection. And people say, why do I need a selection of 4 different types of auger heads just to do this job? And the thing is, we don't know what that sediment is going to be consisting of. And therefore, you should go to site with different heads so that you can use the correct type for the correct sediment. So you may start with one type for the first 50 centimeters, and then you go down and find you're in heavy clay, you use a different one, and then you're in sand and so forth. So using the right tools, and we have these kits which are constructed with different types of auger heads, hand auger heads, so that you always carry something that will allow you to take a sample. And in answer to your question, typically I would say that hand augering to 4 or 5 meters is doable. Now, of course, this would be in a semi-disturbed, you would get a semi-disturbed sample, but 4 to 5 meters should be okay. And to give you some idea into the weight difference, we're looking at carrying your auger set, let's say to 5 meters up the top of the hill, being 15 kilos, as opposed to a mechanized system like the window samplers, which will weigh 250 kilos. So there's a big difference, and I always encourage people to take lighter equipment in the field. It's better for their health. It's much easier to work with, and if you only have 2 or 3 samples to 5 meters, it's a lot easier to do that with hand augers rather than carry mechanized equipment.
Yeah, absolutely, and that explains now, because I had someone say to me that, you know, the important questions that can be asked after the wrong hand augers have been used is things like, you know, why does my back hurt? Why did something snap? I.e., it's not right for the person, it's not right for the equipment if you use the wrong one. But I love the fact that I hadn't thought of it, that you can use a different one so far and then another one and another one, because of course that profile could require that. I mean, just very quickly running through the just a sample of the different types of soils, etc., that it could go into: stony soil, soft soil, clay, coarse sand, combination, riverside, spiral, stone catcher, gouge auger and piston sampler, bipartite augers, augers for prospecting for geological surveys, and volatiles. I mean, that's a massive list, isn't it?
Oh yes, and the list is probably longer than that as well. I want to mention something also about the quality. The quality of the augers that you buy is really important, and unfortunately, quality does come with a higher price. So let's take a standard hand auger, and we see that sometimes we send a quotation and the item costs £150. And we're told, well, we can have these. These are handmade by a company around the corner, and they cost £50. So I'm going to buy the £50 one. I think that is an incorrect purchase. A hand auger will last you mostly for a lifetime. Only where we have people involved in soil science, they come back to us after 5-6 years and they say, look, we've worn this auger down, and they show this with pride, not as a complaint, but they say, yeah, we've taken 10,000 samples with this auger. So buy, from the point of view of augers, buy the best one you can, because you're likely to keep this for life. So it's £150 over 10 years is £15 a year. That's, I don't know how many cups of coffee that is, but that's what, 4 or 5 cups of coffee in the lay-by on the M1. So buy the best quality, whether it is from us or from anybody else. Buy the best quality hand augers that you can. You will not regret that, and you will keep those for a very long time. Also, bear in mind that these people have had decades of experience in producing something that really works well, and we come to the connections which you have alluded to. There are many different types of connections. When I started 40 years ago, everybody wanted a British gas pipe thread. Well, I can tell you that once it's done up, you can't undo them anymore. So that's why you have things like bayonet connections, and now more recently we've gone to something called a hex quick pin, which is a relatively recent for us, about the last 2 years, and customers love it. It's easier to connect together. It's very strong, And you don't need spanners or wrenches to disconnect the extension rods from the augers or the handles from the augers. Chris, going back to the health and safety side, it's important for people to protect their backs. It's important for them to protect their shoulders, their necks, and something that customers or users should be made aware of. If you're using this sporadically once a month for an hour, it's no big deal. If you're using this 8 hours a day for a week, you're going to start feeling the strain of using these devices. And there are accessories that make this easier. For example, a ratchet handle where you don't need to swing the whole auger around, you can actually ratchet that. So that's an addition which people should get if they're using if they're sampling for a long time. Handles specifically constructed so that they are more ergonomic to use, which again save you damaging your shoulders. So it's important for people to consider there are accessories that make their job easier, and those should be discussed. And Nikki does this all the time. As I say, if you're using this once a month, no big deal. If you're using it every day, day in, day out, it's really important to make sure you have the right tool to do the job, but also that you choose the accessories that make your sampling experience easier on the body.
Yeah, absolutely. That is a great point, and I hadn't thought. I love I hadn't realised the ratchet handle. That makes sense. Instead of going all the way round, like the ratchet spanner is, you don't have to keep going all the way round. I like that. That makes a huge amount of sense. One of the ones that I want to go back to, because when you were saying, for example, make sure you get the right one. I love that the false economy argument. So that was one point that I want to use, that phrase, the false economy that is all too easy to fall into. So that makes sense. Speak to us, let us know the job, and we can work out the best equipment for you. And I also want to jump back to the type of hand augers or the what we could be going into. Volatiles. As I mentioned that, I suddenly went, I can't quite remember the details on that. What's volatiles?
Yeah. Okay. So there are compounds that are volatile. What does it mean? It means they evaporate. If you can imagine that you are looking at a site which has had a diesel spill or something like that, you know what it's like. How can I compare that? If you have a jerry can of fuel, a plastic jerry can of fuel in your car, your whole car will smell of fuel, yes?
Yeah.
Now, it's not because your jerry can is leaking. It's because the volatiles are actually going through the plastic and volatilizing. They disappear in the air. And the volatility is dependent on a number of factors, one of them being temperature. The warmer it is, the quicker that volatile action will happen. So if you're specifically sampling for volatiles, it is not possible to use anything which is plastic. Plastic is transparent to the volatiles, if I can put it like that. It'll go through it. You will lose them. And if they are the compounds that you're wanting to measure, it's important to make sure that you retain all of them. And that's why there are specific sets which are constructed all of stainless steel. In fact, in such a way that you can cap off with stainless steel, so you retain as much of the volatiles as possible before they go to the laboratory. So sampling for volatiles is not that straightforward. There is a standard for that. You will capture the samples within a stainless steel sampler. It'll be capped with caps which have the same membrane that you have in wine bottles, which is the aluminium foil in the cap. And by taking them in this particular way, all you're trying to do is retain as much of these volatiles as possible. And actually, don't do this on the Friday evening and leave the samples in your car over the weekend, because by the time it gets to the laboratory, a lot of the volatiles will have gone. And therefore, volatiles is just one of the aspects of where you might want to use specialized augering equipment. If you know you're going to sample for volatiles, make sure you have the correct kit. It's no use having an open hand auger, because as soon as you turn around and you retrieve this, the volatiles will just disappear from the sediment.
That makes sense. That's all right then. I thought it was talking about my wife or something like that. But yes,
Well,
it's
I
let it go. Don't get me in trouble, Vincent. I'm good enough at doing that myself. But the other one as well. What about muds and sludges?
Yeah, no, muds and sludges, by the definition of the term, they are not cohesive. So they flow, and again, you will need to use special samplers. Let me give you an example. You want to take a sample from Poole Harbor, because you want to test for anti-fouling TBT. Now, you're underwater already. You need to capture the sample, and particularly of particular importance is the bit, the surface part of the Poole Harbor, shall we say. And that is a situation where you want the most accurate samples. You want to know, where are these materials, where are they found? And we're looking there at the interface between water and the sediment itself. And sometimes the bit just above the surface of the seabed is as important as the sample itself. It's what we call the heavy water plant. It's where all the sediments are actually swirling around at the base. So you want a totally undisturbed sample of a layer, let's say 30 centimeters into the sediment, but also a little bit outside. So very much you want a very, very accurate profile, so that you know exactly where these materials are, how they're moving and where they are. And that requires very specialized equipment, which is not only expensive, but actually it's quite difficult to use. And again, I come back to the training aspect. This is something that I think if there's something we do well, it's the training of the people to use this equipment. And we spend a lot of time on training users of the equipment. Use the right equipment, make sure you know how to use it, and you will get very good samples.
Absolutely, I can't shout about that loud enough. It's so valid, and it is a big feedback that I hear from our clients all the time.
And there are many types. Sorry, there are many types of mud augers. So you may want to capture the surface, but you may want to go deeper. You may be underwater. So for all these situations, there will be a different sampler, and there's not a one fits all solution. There is no there's no Swiss Army knife that does it. It doesn't exist.
I mean, switching to specifically the auger, and I think it's sort of like possibly the final point really is the auger itself. Does it make a difference what it's made of as well?
Yes. Yeah. We always recommend standard steel, so not stainless steel. And some people say we want a stainless steel. Now we can supply in very specific circumstances, but remember that stainless steel is made with a lot of additives. So let's say you're wanting to sample for chromium, probably stainless steel is not the best, the best material to use that. So ordinary steel is still the best thing. Yes, it rusts, but it doesn't matter. And maybe if this is your final point, I would say also on the maintenance of these things, do not use any additives. You don't want to use greases. You don't want to use cleansers. You want to make sure that you retain just the steel. It'll go rusty, but it doesn't matter because the earth is full of iron. It doesn't matter. Just rinse them off with some clean water, use a brush, and that is all the maintenance you have to do. So from the material point of view, you do not want to use really anything except for ordinary steel.
I think that sums everything up brilliantly. Before I conclude, is there anything else that you think is worth mentioning, Vincent, or have we covered it all?
No, I think we've covered pretty well. Let me just have a look.
It's always dangerous asking you that question because I know that you know so much about it and you get so passionate that if I wind you up and let you go, we could be here for another hour.
No, I think as an introduction, this is pretty good. Just to recap, you need the tool to satisfy the requirements of your project. That is what it's about. So when you're contacting us, let us know a little bit about your project and we can help you choose the right tool for it.
Absolutely. Echo those sentiments. Absolutely brilliant. So there we go. You can see why I wanted to dig deeper into augers. There's so much to it. It is an incredible area. And as Vincent said, get in touch. Let's have that conversation with you and we'll be able to work out what is the right auger or augers for your job. So from Van Walt Limited, thank you very much for your time. I hope you've enjoyed it. Van Walt, the Environment Monitors, will be back again with episode 5 in due course. Keep your eyes peeled. Make sure you subscribe so that you get the notifications when it comes out. And remember, it's available both audio and video on our YouTube channel as well. But from Van Walt, we'll catch up with you next time. Goodbye.
Bye.